Morning, everyone. So, just getting ready for the talk. Sometimes I like to rifle through some of our koans. And if you're not familiar, koan, these are old or ancient stories that Zen passes down from student to teacher, kind of teaching stories, if you will. Kind of parables, but not quite. Um, so, flipping through here, and just look, generally I look to see what jumps out at me. And of course, this one jumped out and it's nice and short. Some of these are longer. This is Blue Cliff record number 50. So a monk asked Uman, what is concentration on every atom? Uman said, food in the bowl, water in the pail. So, of course, I'm a physicist. Of course, this is going to jump out at me. So I figured, why not? We'll talk about this one. And I've always thought that science, physics in particular, and Zen, that in a way they're kindred spirits, right? They're both curious. They both embrace don't know mind. They're trying to look for the truth for what is. They're trying to understand the world. They use very different tools, right? Science is very objective, rigorous scientific method. They like their controls. So it's a very different approach. Whereas Zen and other traditions that are contemplative, right? We're looking within, we're examining. In a sense, we're our own laboratory, right inside. So very different method, um, but they're both trying to get at the truth of things. And um, the thing about both is it's very easy to look at science or look at a Zen practice, and at the surface level, that makes sense. But when you look deeper and you really dive into it, it gets a little more bizarre and harder to understand and obscure. Some of the deeper teachings or more advanced teachings. So I think that's one of the things that drew me to Zen in particular. So this koan in particular called to me. The monk asked Uman, what is concentration on every atom? Uman said, food in the bowl, water in the pail. And I was a bit surprised to see, these koans are, hundreds and hundreds of years old. So I was a little surprised to see a koan that was probably from the 1200s, give or take, somewhere in there. Earlier. Yeah. Using the word atom. And so I looked in other translations, and some will use the word particle instead of atom. But I wanted to look at that. And what I found was that the Chinese actually did not have any ideas about atoms. But much to my pleasant surprise, the Indians did, right? Buddhism came out of India, made its way to China. And so the Indians are very philosophical in their approach to Buddhism. So it doesn't surprise me, actually, that they had ideas about atoms. And this predates the Greeks who did it later. Um, so those ideas came with the Indians to China, and I think that's how it made its way into this particular story. So I thought it'd be interesting before looking at the Dharma perspective of the koan is to dive into that history a little bit. And I found an interesting explanation of Indian philosophy. I won't quite call it a theory because they weren't able to test it, right? They didn't have the instruments to actually test it. So it was a little more of a philosophy. Um, but this theory that I'll talk about, philosophy, is contemporary with Shakyamuni Buddha. So it's that old, 2,700 years or more. And so I'm sure I'll mispronounce his name, but I wanted to give him credit. So the history here is from a Dr. Santanu Bhattacharya. And I'll apologize. I'm sure I got that wrong. So to kind of paraphrase some of his words on the history, it's interesting. So it's been suggested that Kashapa, or in the lineage, right? Shakyamuni Buddha, Mahakashapa is the second in the Buddhist lineage. That this atomic theory came from him. Now, in reality, it was probably contemporary with him, and it was probably multiple Indian philosophers that all contributed to it, but it's really kind of nice to attribute it to one famous person. So Kashapa is that famous person. Um, but yeah, this was formulated about 2,500 years before the discovery of atoms in the West, and so it's an ancient idea. He, Mahakashapa founded the Vaisheshika school of Indian philosophy, and that was kind of led to some of the earlier ideas that led to Indian physics. And he used this to explain the creation and existence of the universe by proposing an atomic theory and applied his just logic and reason to reason it out. And so the story, I don't think reality is quite the story, but the story where this came from is that once he was on an expedition and he saw streets littered with flowers and rice grain because they were being presented at the temple, or sorry, the temple as a symbol of respect. And fascinated by the broken grains of rice spread in the streets, because people are walking the streets and they're breaking the grains of rice. Uh, and a crowd gathered around him and asked him why he was collecting the leftover grains that even a beggar would not eat. And he replied that while the individual grain particles may not have any worth, a collection of hundreds of grain can make up a person's meal. The collection of many such meals would serve as an entire family, or would serve an entire family, and ultimately would feed entire mankind. Therefore, even a single grain of rice is important as all the valuable riches in the world. And so, impressed by this thought, they gave him the name of Kananda, or Kan, which in Sanskrit means smallest particle. So every particle, every grain of rice was important, even the broken grains of rice. And so the story goes that Kananda or Kashapa was walking with the food in his hand, breaking it into small pieces when he realized that he was unable to divide the food any further. And from this moment, he conceptualized the idea of a particle, something dividing it up so much that I couldn't divide it anymore. And this was his idea of Parmanu or Anu or atom. So that thing that you could not divide anymore was his idea of an atom. And it's amazing to me how close he got to what atoms really are. So here's some of the things that I should say they reasoned out. I'm sure it was more than just him. So everything can be partitioned. Everything matter can be partitioned. So yes. Subdivision leads to the creation of atoms after a while, right? You divide it down. Eventually you get to atoms. Then the atoms are indivisible. That is, they cannot be divided any farther. He didn't get that one right. You can, right? It takes a lot of energy, but you can divide atoms, right? Into the nucleus and the electrons. And even within the nucleus, this is where I did my research as a grad student, you can even break apart the pieces inside of the nucleus into even smaller things. But it wasn't all wrong, because certain things like the electron, I think that perhaps we can't divide that any further. Maybe. So maybe I think we just move the goalposts a little bit. I heard someone say, yeah, we don't know how small the electron is, because how do you measure something small? You get something smaller and you figure out how many of those does it take. Well, we haven't found anything smaller. So there's still pieces that we think are perhaps indivisible. Subsection of any particle has an end and cannot be carried infinitely. I have to think about that one. Atoms are indestructible? No, not quite. But perhaps some of the pieces within are indestructible. It is the foundation for all material existence, yes. And the atoms have specific property which is the same as the class of the substance to which it belongs. So carbon, right? Down to that carbon atom. That carbon atom has the same properties as a hunk of carbon. You can combine them in different ways. He was right about that in chemical changes. So there's a lot of things that he got right here. Um, the thing that was really interesting is he was estimating the size. Now he's just doing this as a thought experiment, right? Just looking at it with his mind. And so what he reasoned was, and I'll actually go backwards here, that the size of a finger, right? If you take that and divide that by 8, you get roughly the size of a barley corn. Divide that by, I don't know why they liked 8. They liked 8. Indians love their numbers. They divide that by 8, now you're the size of a louse. Divide that by 8, you're the size of a nit. Divide that by 8, the end of a hair. And divide that by 8, the atom. That was their idea. Now, being the physicist that I am, I had to do a calculation. It tickles me to death that I finally got to do a calculation for a Dharma talk. If I ever get to do calculus for a Dharma talk, I'll think I'll just disappear off into nirvana and be happy. Turns out that he was off by roughly 60,000 times. The carbon atom is 60,000 times smaller than what he suggested. So dividing by 8. So you take what he thought an atom was, divide it by 8 again, divide it by 8 again, one more time, and then by a third. And now you're down to a carbon atom. So reality is so often so impossibly beyond what our imaginations can even fathom. So he was off by 60,000 times, but it's still remarkable. His idea wasn't wrong. It's just he didn't divide far enough, and he didn't have any way of knowing or measuring. So all of this, so I thought this was fascinating. They really did have this atomic theory, and it wasn't that bad, or it was close. So this story then makes its way to China. A monk asked Uman, "What is concentration on every atom?" So that's the question. And so thinking back to this theory and giving this to a young Chinese monk. And they're, of course, told about atomic theory and how all of this, right, everything is made of these infinitesimally small atoms. What does it mean to concentrate or to sit with or to meditate on every atom? This is where Uman says, food in the bowl, water in the pail. So yesterday we had our little retreat, and when I sit, I like sitting with whatever topic I have. And so I was sitting with this atomic theory, which was an interest. I've never done that while sitting before, thinking about atoms. But it occurred to me that there's some parallels between this theory of atoms and our practice, right? Think about the atom. It takes an enormous amount of energy to pull apart an atom, right? This thing that seems to be indivisible, and to Kashyapa, his idea was that it was indivisible. But we know that if you put a lot of energy into it, you can take it apart. And again, looking at the parallels with the practice, it seems to me that our internal self-delusions are a lot like that. When we discover them, oh, that's real. That's solid. And it often takes a lot of energy to to tease that apart. And often it takes great turmoil before we can get to that point. And I was also thinking about some of the modern experiments. Thomas Rutherford, 1911. He was trying to figure out, well, what are these atoms? He actually took gold and hammered it so thin that it was just a couple of atoms thick, really thin foil, and then set up radium as a kind of a radiation source and would bombard this with something called alpha particles, just little particles. And they knew about atoms, but they didn't know anything about the properties of the atoms. And so he was expecting to see it bounce off the gold, right? Maybe fit through the cracks between the atoms is kind of what he was expecting. Maybe a little bit to get through. What he found was the opposite. 99% of the particles went straight through the foil as if it wasn't there. Just went straight through. Every once in a while, some would bounce back. Less than 1% would bounce back. And it was from that that he realized and came up with the theory about the internal structure, right? The little nucleus, little hard nucleus that's less than 1%, and the electrons that are floating around it, not floating, but they're in this kind of cloud around it. So we are mostly not here. Most of the space we take up is empty. And so I was sitting with that, right? Sitting with the idea that my body is mostly not here. This is 99% empty space. Yet to me, it feels solid. So how much less real is the self, right? It feels real, but it is built upon a house of cards, right? It's built upon this, it's like an internal concept born of this interconnected neural pathways that are in our mind, in our body, shaped by our biology, our karma. It's dependent upon all of the atoms, which are essentially empty themselves. So where is the self? So when you look at that way, I think the Buddhists were onto something when saying there is no self or no permanent self. Um, you, you can almost imagine me thinking, kind of eating my rice out of the bowl as I'm kind of thinking this through, right? So the material world that we see is largely an illusion. Right? It's a picture, it's a model that we have in our mind that we have to have in order to function in an everyday world, but it's not real or not accurate. Maybe that's a better way, right? Mm-hmm. There is no fixed permanent self, no more than the gold is solid, no more than this body is solid. So all of these ideas, our understanding of the world through science, our understanding of ourselves through both science and our practice, philosophy, technology, psychology, and yet despite all this, Uman had the right of it, right? Food in the bowl, water in the pail. All of our ideas and practices are wonderful, but what now? Right? Sitting before that bowl of rice and that pail of water, what now? What do I do? Similarly, we can talk about loving kindness. We can talk about walking the bodhisattva path, but sitting in front of another person, seeing the challenges they face, what now? What do you do? We may not be able to break apart that person, right? Like atoms, right? I don't know really what's there, but yet here we are. What now? What do we do? Food in the bowl, water in the pail. Of course, without our practice, we'd probably give a different answer to that question, right? What now? I think our practice helps give us, perhaps make us more skilled, perhaps. Maybe it depends on the day. um, but I think at some point we need to transcend our practice. At some point, each of us must leave the practice behind in a sense, much like a jazz musician, right? Jazz, right? They start with this sheet of music, but they leave it behind with this creative improvisation. And much like that, right? We take our sheet music, which is our sitting meditation, our walking meditation, some of our ritual, the sutras, that's our sheet music. At some point, we need to leave that behind so that moment by moment by moment, we can ask ourselves, what's needed now? What is this moment all for? It's this natural flowing that I don't know that the word practice quite fits. I mean, you could say it's a practice, but it's the flowing Dharma moment to moment. So when you contemplate the atoms of the universe, you kind of think about these kinds of things, right? What is this? Right? What is this? But what now? Ultimately what's important is how do I flow in this moment? How do I be fully present in this moment? So atoms. This did have a nice verse. Oh, you can tell how nerdy I am. My bookmark, I grabbed a random piece of paper, happens to be a circuit card that I'm working on. I printed out. So yes, I am that guy. uh, Embrace your nature. I am a nerd. The verse, food in the bowl, water in the pail. The talkative teacher could hardly open his mouth, although I have tried. The North Star and the South Star don't change positions. White waves flooding the skies arrive on even ground. Trying doesn't apply. Stopping does not stop. Each one a rich kid with no britches. Britches, pants. Yeah, I like that one. That last line in particular. Each one's a rich kid with no britches, right? All of us have access to the unborn Buddha mind. We all have access. We're all rich kids, and yet here I am giving my Dharma talk, trying to help you all find your britches. So I'll leave it with that and open it up for discussion.